through all of them. But please, if you have questions, stop me and ask. Okay, so first, oh, and I apologize, there was a typo right at the beginning. Where it says chapter 1, chapter quiz, that should have been page 30. At least on my sheet it says page 20. So that was supposed to be page 3. If you look for the chapter 1 quiz, you should have found it. Sorry about that. So here's going to be number 2 and number 8. Is the name of your favorite author qualitative or quantitative? Qualitative. Yes, qualitative. It's a name, it's like a category. Now, the review problems, you don't need to hand those in. If you did, it's okay. But I don't look at those. They're just to help you practice for the test. The manager of a restaurant walks around, asks selected customers about the service they've received. Which type of sample does this represent?
Observational convenience.
Convenience is the word. I heard a couple other answers that would be true, but convenience is the word we want. You're just doing what's easy for you. Just walking around in your restaurant. Like if I used you all for example of students, it'd be convenient. Then on the next page, in the next page in the review exercises, I distinguish because you've got your quizzes and then your review exercises. So number 1 on that one.
We can write on this yellow sheet for the test, right?
Yes, thank you for mentioning that. I wanted to reiterate that. You can write on that yellow sheet, the one with your formula. So if we're covering something you're a little fuzzy on, feel free to write on that. Is the number of points scored in a football game qualitative or quantitative? Exactly. It's a number that does represent a quantity. And then number 3, discrete or continuous. Remember, quantitative can be either discrete or continuous. The area of a college campus. It is actually continuous. This is not a technical definition, but things that you measure, those are generally continuous. Things that you count are discrete. And part of the definition of discrete is countable. So just ask yourself, is this something I would count, like how many classes I'm taking? Or is this something I would measure, like area, height, weight, time?
So continuous is what you can measure?
Yes. The technical definition is it happens on the values take on an interval of the real number value, technically. So in other words, there are an infinite number of possible values. But a working definition, if it's something you measure, it's going to be continuous. That is number 3. And then number 8. 3 was continuous, that was area, time, height, weight, those are continuous. I don't know if it'll come up later, but what's an example of something discrete? Anyone Pardon?
Siblings?
Yes,
Siblings?
how many siblings you have, exactly, that's perfect. It's something you count. You're not gonna have 2.758 siblings. Yeah, something you can count on your fingers. Good. So on number 8, a pollster obtains a list of registered voters, uses a computer random number generator to choose 100 of them, to ask which candidate to prefer. That one is what type of sample?
Same sample?
Yes, exactly, you got it. And those questions would be multiple choice. It was like A, simple random sample, B, convenience. So convenience, there's no randomness involved. You just pick what's convenient for you. And that one, you use random numbers to count, or use random. So then 11 and 12, we're going to compare observational studies to designed experiments, randomized experiments.
You said you're not testing me for
Did I say that it wouldn't be on there? Oh, okay, thank you. So we'll skim over that. Yeah, if I said it wasn't on there, then I didn't put it on there. Yeah, we ran out of time or something, right? What happened that day? Okay, so on to chapter 2, page 82. Number 1, and then number 2. I guess I put some directions on there. So 1, 2, and 3. Oh, I may have to project my book out for some reason. Okay, sorry, I'm going to just get out of here and get back in because it's messed up. That may be the reason. So I'll just use my pen. Project it up here. So let me have your notes with you. I think this is about as good as I can get it with this thing. So problems 1, 2, and 3. We have a list of letter grades, and it says in number 1 to make a frequency distribution. So they range from A through F, and this is qualitative data. It's not something that you count or measure. There are different categories of grades. So you list each of the different values, each of the different categories. And then we'll just count how many of each grade we have. That's the frequency. Did anybody get 8 A's?
I got
I
9.
got
9? Okay, we'll go with what? I'll just ask you all what you got. And then if you counted how many B's, what did everyone get?
5.
5? Anybody not get 5? Go with that. And C's? Count how many C's?
6.
Just tell me if anyone disagrees with these. And D's, how many D's?
3.
And F's?
4.
Okay. So whatever your categories are, you just simply count how many each. And you'll have the test, you can cross them off as you count, so it'll be easier. And then I like to put a total row. So we have 14, 20, 27, it looks like altogether. Did anybody get a different total than that? Okay. And so that's number 1, would be that. Number 2 said do relative frequency. We'll just put it on the same table. And if I asked you for both of them on the test, you could just put it on the same table. And your relative frequency, that adds up to 1 or 100%. And on the test, if I tell you to take something out a certain number of decimal places, then do. You'll lose a half a point if you don't. But if I don't say, you can round it off however you want. So I'm taking these out 3 decimal places or to the nearest thousand. Any almost for sure, most of these things we're doing, they'll almost for sure be one of them on the test. There may be one or two things I left out there. Please ask if you have any questions. So we're on page 82 right now. And the next step is to make a relative frequency graph, I think, or, just a frequency graph, so straight up frequency. So if it's a relative frequency, the height would be these numbers. If it's a frequency, the height of the bars will be those numbers. But I'll have the same shape either way. So our highest frequency was 9. We need the 9. And you could write frequency at the top, or you could put it on the slide over here. I think I'm not going to bother to label it. The vertical bar is your frequency, or your relative frequency. And then you have, for each category, you have a bar. So A, B, C, D, F. So we're going to have 5 bars. And I'm not going to be particular that you get the scale perfectly. It's kind of hard when you're drawing it freehand. But in practice, you want the widths to be the same so that the area of the bar represents the proportion. So try to give them, bars similar. So there were 9 A's, so the height of the A bar goes up to 9. 5 B's, so the B bar goes up to 5. And they should all be, like I said, the same width line. I was terrible at drawing, so it's not going to work that way. 6 C, B bar goes up to 6. 3 D's. If we did relative frequency, it would have the same shape. You just have the proportions over here on the left side. Any questions on any of those?
This is a histogram of the bars touch.
Yes. If we had quantitative data, we would make the bars touch. Yeah. I didn't have you draw a histogram on the test because everybody will do on project part 1. But you're absolutely right. On your project, when you make your histogram, you do want your bars to touch.
And does it matter on the X axis if it goes from F to A or A to F?
No, it's however you wanted to put it. There is a type of graph, bar graph, and I don't think we have it mentioned in our book, called a Pareto chart. If you see something called a Pareto chart, it's just a bar graph where you have them in descending order. So if we did that way, we'd have this one, and this one, this one.
Okay.
But no, that's how you put your categories, that's up to you. For me, if it's, this is actually an ordinal qualitative variable, we never got to that level of detail. But if it's something that has a natural ordering, I would put it in order. But there's no law that says you have to. Okay, then, that was 1, 2, 3. So number 9 now. Let me just see if I can get back into, mine's on a different page. I think there was something marking on page 82. It's just so much easier to read. Oh, good. Back to this. I have some special direction on number 9. You only need to list the smallest and largest. So the minimum number and the maximum number. So they don't give us a key, but they do say the leaf represents the ones digit. So these are the ones, and therefore the stems would be the tens. So the smallest one, well, the smallest stem is 1, and the smallest leaf on that stem is 1. So the smallest, they don't tell us what these numbers represent, but the smallest number in the data set is 11. And the maximum, well, the biggest stem is 5, the 50s, and on that stem, the biggest leaf is 8. So the largest number in the data set is 58. And you could get your entire data set there. I'm just going to have you sit and write down 20 numbers away. Okay, so we did that one. And then number 10, construct a stem and leaf plot. Okay, so now we have the raw data and we're going to make one of these plots. So our data is similar to the data here. We just have 2 digits, the 1 digit and the tens. Our smallest stem will be 1 for the teens. There's a 68. 68 is the biggest one. So we need to go from 1 to 6 for our stems. And then we just put the leaf for each of our prices of copy leaves. So there's only 1 in the teens, so we have a 9 there. In the 20s, we've got 28, 29, 28, and another 22. We have 2 22s. So you have to put a stem for each of those.
There's 2 8s.
Oh, 2 8s, thank you very much. So repeated values, you put the leaf for both of them. So there's a leaf on there for every observed value. What about the 30s? Is it just the 5, 7, and 9? It looks like they're in order. Technically, this is called an ordered stem plot, and some people make them not in order. I always want them in order. Yeah. And did we have any in, yep, we have 41. Was that the only one? And 50s, were there any? No. And so then we have our 8 listed. So notice we did put a stem for the 50s, even though there weren't any. You start with your smallest stem and end with the largest, and even if there are blanks, you still put that stem there. And if we made a histogram and went with class width of 10, it would have the same shape as the stem plot, since the stems are like this. Page number 13. A dot plot for the data. Okay, the data we just did, now we're going to do a dot plot. So you make a number line, and I may have drawn a number line for you, I can't remember. But in any case, you make a number line, and I guess I'll go by tens. Might be more precise if we had smaller units, but. And you put labels on these things. I'm not going to require you to have a label on the exam. And on the dot plot, the name says it, you're going to put dots up above the number line for each cross, for each. Dot up above 19, there were 2 22s. Two dots. If you have repeated values, you stack your dots vertically. You also had 2 28s. Nine. 35, 37, 39. The dots are painted big for my little scale up there. And a 41 and a 68. So they're both nice in their own way. Here we have values grouped together, so you can see the shape like you would with a histogram. Here you've got a dot for each specific value, so it's a more detailed display. In both cases, you probably wouldn't want these for really huge data sets, especially the dot plot. People use that when they have little tiny data sets, because you don't have much data to do. Okay, so that was number 13. And then on the next page, number 1, A and B. Were there any questions on either the stem plot or the dot plot? This will almost for sure be one of each of those I expect. Sometimes I'll leave one of them off just so it's not too long. So this is qualitative. Different categories, people had choices, different categories of how much they trust their doctor. So part A says, which was the most frequently given answer? Yes, you just look for the longest bar. Notice on this bar graph they used horizontal bars because some of the categories were kind of long. It'd be hard to, some are short and some are long. It'd be kind of messy to try to put those on the horizontal. True or false? Less than 1/4 said they trusted their doctor completely. Right, because here's completely, here's 1/4, and it's not quite up there. So, done together. On number 2, they give us prices for personal computers. And it says calculate the mean, median, and mode. And then on number 3, it says, what if we had a computer that cost $2,000, which is affected more the mean or the median? So we'll just add it in here. Now, before we go to the calculator, because we'll let the calculator do the work for us. What is the mode? Because calculator doesn't pop out the mode.
550?
Yes, except 550. That's the value that occurs most frequently. It's the only really good value. So our mode is 550. The rest of it we get from the calculator. And I do have one learner calculator left. I don't know whether everybody's still in. So you go to Stat, press Enter. That's, I don't know what that's from. I'm going to leave that in case we move to homework and I find out that that was a homework problem. But you can clear out list 1 if you have stuff in there you don't care about.